Today, guys, we're going to do a metric lab on volume, which is about how much space something fills. And we're going to be using several different bits of equipment here. You're going to have a test tube rack. You're going to have a series of test tubes. You're going to have what's called a graduated cylinder. They may be glass, be careful, most of them are plastic. You're going to have 3 different colors of water, red, blue, and yellow water. And you're going to be using something called a pipette, which is for sucking up little amounts. And you're also going to be using something called a centrifuge tube or a conical tube. And this is for measuring small amounts of liquid, in addition to the graduated cylinder, which is for measuring liquid as well. And it's going to be a fun lab. You guys are going to really enjoy it.
All right, everyone. So now I'm going to be doing the procedure, all right, for our volume color lab. So that's part 2 of your lab sheet. And it gives me 9 different steps that I'm going to do. And if I do them accurately and correctly, I should get a pretty cool result. Now, step 1 says to measure 17 milliliters of red water from the beaker and pour into test tube A. So my test tubes do not have any measurements on them, so I can't just pour into this. I have to find out what 17 milliliters of red liquid is first before I pour it into the test tube, okay? To do that, I'm gonna use my graduated cylinder to start, and I want to get up to 2 lines past this one right here, right? Because this big line is between 20 and 10, which is 15, right? Because every line goes up by 1 milliliter. So I want to get 2 past that, and that would give me 17, okay? So there's many different ways you can get to 17 milliliters. You could use your small little test tube here, right? Or you could use graduate cylinder, whatever you want. I'm gonna get close to my graduate cylinder and then finish it off with my eyedropper, okay? So I'm gonna pour here, and it's always good to pour directly over, right? Being very careful as we pour. Whoop. That was pretty close. So it looks like if I read at the bottom of my meniscus, so now I'm getting down at eye level, I'm sitting actually right about 15 right now, okay? And the meniscus, remember from the prior video, right? We want to read at the bottom of the curve, okay? So it's dipping down and touching 15. So to get to 17, I need to add 2 more milliliters. So I'm going to use this small guy to get a more precise measurement and get it to 2 milliliters. And I'm going to use my eyedropper. I'm going to put some red liquid in, and perfect. So when I look here, okay, it's sitting right at 2 milliliters, so I can pour it in and be confident that it's going to be 17 milliliters. Very close too. Remember, it's all about accuracy and precision. So now I'm at 17 milliliters, and I need to pour it into what test tube? Test tube A, okay? Which is my first one right here. And I'm going to go ahead and pour that in carefully, making sure that I don't spill any, because that would throw off my lab. Make sure you get all the drops out, best you can. And that's step 1. Okay, so now I'm gonna roll into step 2 and keep going through that. I'm not gonna talk through every single one, right? But we're gonna pick it back up when we get to step 4.
So we have completed steps 1, 2, and 3. We've put 17 milliliters of red into test tube A. We've put 21 milliliters of yellow in test tube C, and we have put 22 milliliters of blue into test tube E. This next step, though, is not going to use these larger volumes of liquid. We're going to be moving liquids around inside the test tubes, and this is where things get a little bit more specific, and you have to be a little bit more careful. We're going to take 5 milliliters of red from test tube A, and we're going to put it into test tube B. Now, my graduated cylinder does not really measure volumes that well when it's that small, so we're going to use this smaller centrifuge tube or conical tube to measure those 5 milliliters. So I'm going to simply use my syringe here, my pipette. I'm going to pull up an amount, and I'm going to add it here. And I have about 2 milliliters. I'm going to do it again. This will probably get me closer to 4. And then I have to get to 5, so that'll just take a little bit more. And then now I'm going to be careful. I don't want to go too far over. Just going right to 5.
Careful, Mr. Franchi, careful.
I know, I got to be
Careful.
really careful. Now,
Stop.
the meniscus on plastic is not quite as easy to see as it is if it was glass, but it is there. So just be careful. And now we just pour it right into test tube B. Be sure to get as much liquid in as you can. Every drop is precious. Okay, that's about as long as I got. Okay, don't bang it too hard. Actually, don't bang it at all. All right, there we go. That is step 4. And then we'll go steps 5 through 9, and you'll see the glorious result when we are finished.
Okay, so Mr. Franchina and I went through the rest of the steps, and this was our final result. Kind of cool, right? So if you did this lab accurately and correctly, 2 things should have happened. Number 1, you should have had the rainbow, right? Nice little rainbow here of colors. And also, all the amounts in each test tube should have been level. This should be level going from left to right, okay? So all of them should have the same amount of liquid. Now, you might be able to see ours isn't quite perfect. So there might have been some instances where we, or I, maybe, Mr. Branchino is perfect, but it probably was me. No. Messed up a measurement, or maybe we missed a drop of water, something like that. But what we're gonna do now is we wanna see how accurate we were, okay? The goal is that every test tube has 10 milliliters of water in it, okay? But we're gonna go through each test tube now, we're gonna measure how much we have in each, and then we're gonna record it in our lab report in the third section, okay? We're gonna write the color it is and how much of it we have in milliliters. So to do that, we're gonna use our little centrifuge guys, right? And we're gonna see how much we have in each. So we'll join you when we're done with that.
All right, we finished our measurements. They weren't as accurate as I would have liked, but that's okay. It's always important to kind of learn from how you do your work. And we have some ideas about why maybe ours didn't come out quite as accurately as we'd like. The red was 9 milliliters. Orange was 9.5 milliliters. Yellow was 10.5. Green was 9.5. Blue was approximately 2 and 2.2. And purple was 9.5.
9.2.
Oh, 9.2. What did I say, 2.2?
2.2.
Oh, sorry, 9.2. That was really bad. 9.2 and 9.5. So we looked back and we said, why is our volume so low? It should have been about 10. Why isn't it 10? Well, you can look right here. I don't know if you can see, but if you look here at the bottom, you'll notice there is some blue liquid remaining at the bottom of this conical tube. You'll notice that there is liquid still resting inside the test tube up here that is not residing down here where it's being measured. We lost liquid in our transferring of liquids back and forth. Some liquid was left behind. You might not think these drops matter much, but they really do. They add up quite quickly. A milliliter of water can add up very fast. The volume of a milliliter is roughly about the size of a quarter, so it doesn't take much to have that. So I think in our transitions we lost a little bit, perhaps. They lost some in a graduated cylinder, but next time we do this we will try to be better. And that's it. All right, so we're going to do the volume lab, and the part that we're going to do here is Part D, the color challenge, is what we're looking at here. Mr. Buckwalter and I, followed the directions very carefully with our materials, and then we were very, very careful to follow our outline here, our steps that we needed to do. And what we ended up getting was the following. As we mixed these colors together according to the directions, we found that we got in test tube A, it was a red color. And at the end, when we finally poured it out, we found out that we had 9.5 milliliters. Then for test tube B, it was an orange color, also with 9.5 milliliters. We did yellow in test tube C. This was a little more. It was 10.5 milliliters, and I'll talk a little bit about why I think that happened. Then we had test tube D, which was green, at about 9.5 milliliters. and test tube E was blue at 9.2 milliliters or thereabouts. It was slightly less than 9.5. And finally, the test tube F was purple or a violet, and that was at 9.5 milliliters as well. The variation here, we were really expecting to get 10 milliliters for everything. And the variation is most likely because inside our test tubes, there were droplets of water clinging to the sides. The graduated cylinder also had droplets clinging to the insides. And even though there aren't many, they do add up. And they do add up to a significant amount. And so that's why we're kind of short by about half a milliliter, which is quite small amount. So this isn't a huge problem for us. But it is important in chemistry to make sure that we're not losing volume to droplets clinging to the sides. Now, you probably saw Mr. Buckwalter and I putting our eyes very, very close to the graduated cylinders, and that's because when we were measuring here, when we were looking at the graduated cylinder, we care a great deal about making careful measurements. And what you'll find is when water is in a graduated cylinder, it forms this kind of curve. It kind of forms this curve here, this crescent, and it clings to the sides of the glass here and here, and that's because the water is sticky and it has a property called adhesion, where it sticks to things other than itself, like sides of glasses and so on. When you come out of the water sticks to you. It's adhesive. Now, because of this, where do we measure the volume of the water? Do I measure up here at this line, or do I measure down here? And then, as it turns out, we are supposed to measure liquids at what is called the meniscus, which is at this bottom lower portion right here at the bottom. And so you look at where the curve ends at the bottom, and that's where we measure, and it's called the meniscus. And it's a Greek word meaning crescent. There you go. Helps if I could spell it properly, like a crescent moon. So that's where that comes from. So we measure the meniscus at the bottom there, and that helps us make our measurements accurate. Also, you probably saw me holding the graduated cylinder or holding the base. The base is very, very essential because it's very, very easy to tip your graduated cylinder if there's nothing holding it. If you bump it from the top, it will. So if you're working with a graduated cylinder and you bump it from the top, it's very, very top heavy and it will easily topple over. It's important to secure it by holding down the bottom so it doesn't go anywhere. So that was our lab today, guys. We measured out the different volumes. We were supposed to get 10 milliliters. We didn't because we had a little variability here with our droplets. And we measured it by looking for what's called the meniscus, which is Greek for crescent. And we look at the very, very bottom of that curve of the water. And that's how you do it. All right, have a good one.